after some time.
Don't control. I mean, literally somebody could be sitting at their desk within the confines of the office that I control, yet they're on an iPad that they own, they're on a 4G network, 3G network that I don't control, and they're uploading their data to Dropbox. And now all of this architecture that I've spent millions of dollars on to be inspecting all this traffic has been completely bypassed. And it's a very different ecosystem, as we'll see, in terms of the types of threats that we need to be concerned about. So we've always had to deal with all these different threats. Simple ones, adware, spyware, all the way up to some of the targeted exploits, advanced persistent threats. And historically, we've thrown appliances at the problem, things that do blacklisting, antivirus, intrusion detection, behavioral analysis. And the challenge there is that as we add more, of course, the amount of effort increases. But that's not a realistic scenario. We don't typically just throw out one location and we throw a single appliance at the problem. More typically, we have to have multiple locations, redundant appliances. So we've always had this sort of escalating level of effort for the CISO. Now mobile comes along and blows us all out of the water. Because that scenario I mentioned where the individual's sitting at their desktop, but they're on some 4G network, their traffic is bypassing all of these hardware appliances, all of these controls that we've had in place. So we have to rethink things. We don't have the same level of ability to protect using the old way of doing things. We certainly don't have the same visibility. You know, somebody's out at a coffee shop working on their laptop. Well, that data may never make it back to my SIEM solution, and I may never get logging on it. So mobile is really turning things upside down. But let's look at the devices and the underlying operating systems themselves. Laptop OS, quite open. An application can really access just about anything unless you lock it down. It can access a file system, can access other applications. Mobile operating systems, much more sandbox. So that is, from a security perspective, a positive thing, a very different architecture on both Android and iOS. Network, typically I had control over the network with the laptop. I lose control because of the 3G, 4G access. Traffic, most web traffic from a laptop comes from the browser, so I can focus on security controls at the browser level. More than half the traffic, the web traffic from a mobile device, actually comes from applications. Really think of applications as custom web browsers, because virtually all of the networking traffic that they do is web traffic. In fact, they often just have a built-in web object, web browser object within them. From a security standpoint on the browser side, this is where it isn't good. Desktop browsers have started poor, but we layered on security, blacklist, ASLR, DAP, all these things. And mobile browsers, we kind of started from scratch. The early versions of Android and iOS browsers really had no security, and we're only getting basic security now. Installing applications, very different. My laptop, I throw a CD in, install from anywhere. Mobile devices, we have this whole App Store ecosystem, which should, in theory, improve security, because applications are blessed, but as we'll see, it has its own challenges. And then there's the whole issue of BYOD. Now, every year, we read all these security predictions. My company always asks me to write security predictions, and one security prediction I know is going to come out every year is this is the year of mobile malware. And I've been hearing this prediction for probably about 10 years. I think that we're waiting for the wrong thing. You know, we're waiting for mobile malware to be exactly the same as it was in the PC world. And that day will actually never come. It doesn't mean that it's going to be better or worse. It's just going to be different. And let me try to illustrate that point. We see different types of threats. Is mobile malware on the rise? Absolutely. You know, this chart shows that. We're seeing this hockey stick curve. Mobile malware is taking off. And if you look at the numbers, you know, last year we had about 30,000 unique variants. That's a lot. Not nearly what we see on the PC side. But also look at the colors of the bar. The blue part, almost all of the malware that we're seeing on the mobile side is fake or cloned applications. So this is not drive-by downloads, this isn't 0 days, this isn't known exploitation. This is somebody being tricked. It's a social engineering attack, being tricked into installing an application on the phone. So people are shooting themselves in the foot. And almost all of it is coming from fake, or not fake, but non-official app stores. So we have a problem, but it's very different. In the PC world, the volume is far, far greater. We're into the tens of millions of samples of malicious variants. Now, certainly the PC world has had a big head start. I'm not suggesting that mobile won't get there. But we are seeing, at this stage of the game, very different threats. Not necessarily because mobile is in some way more secure. The attackers work to the level that they have to. And thus far, they haven't had to work that hard. They're having great success simply putting out fake and cloned applications, and people are willing to install them because they think they're saving $1 or $2. So they haven't had to raise their game. What we're seeing in mobile is not that different than what we saw in the PC world. This chart shows that the exponential growth, that's a logarithmic curve of just the number of domain names that were registered. And you can see, back more than a decade ago, we just saw this massive jump from virtually no web content to millions and millions of sites. And it was at a time when everyone overnight became a web developer. Suddenly people that had no experience, I know my brother-in-law started his career this way. He started a web development company literally overnight, announced the company, knew nothing about it, grabbed a book, studied up, and today he's a very, very successful man doing it. He fooled a few people along the way. And now we're seeing the same thing in that applications have just taken off, mobile apps. And so overnight, we suddenly have all these people who are mobile app developers. Well, when that happens, there's going to be this learning curve. We don't have good security tools in mobile. We don't have good skill sets. So we're seeing a lot of poorly coded applications. There's a lot of low-hanging fruit, just as we saw in the web app world. A lot of SQL injection, a lot of cross-site scripting. We're seeing the equivalent to that in the mobile world. So there are plenty of mobile challenges. I was on a panel yesterday where we talked about BYOD. We didn't have to deal with that in the laptop world a decade ago. Visibility is a huge challenge. We've always struggled with visibility. We have multiple offices, getting all those logs consolidated. Now we're adding a big headache to that, whereby I never see the traffic from that mobile device because it never goes through anything that I own and control. It doesn't go through a proxy that I manage. The concept of hyper-growth, that these applications are just exploding and everyone's a developer, and traditional endpoint security, I'm sorry, it's dead. We relied on appliances to be filtering traffic. If that traffic is on a 4G network, we don't see that. That is no good to me anymore. And antivirus is dead as well in the mobile world. Not only is it a bad user experience, but because it can be a battery drain, but it doesn't have the same levels of access. And in the iOS world, Apple has said, no, nothing runs in the background, can't have AV. So these staples that we've built our entire enterprise security practice on are gone. So what do we need to focus on? Well, when it comes to mobile, if we're going to have policies, we need to focus on a few things. We need to identify, say, hey, who is this person? What device are they using? What application are they using? And what data do they have? And that's when, if we have that level of knowledge, then we can make some decisions. We may want to make productivity decisions. I just do or do not want the person using this application because it's not job related. We certainly have security concerns. Is this a malicious or a vulnerable app? But the piece that I feel hasn't gotten nearly the attention it deserves in the mobile world is the privacy side. We are seeing an amazing volume of applications that either intentionally or unintentionally are violating the end user's privacy. And the app stores are not doing a good job of filtering that out. They're focused on the security piece. They're not focused on the privacy piece. In some way, they have some conflicts of interest. So as mentioned, most of what we're seeing from a malicious standpoint is fake or cloned applications. We don't see this in the official app stores, Amazon, Google, Apple. We see this in non-official app stores. The vast majority of it comes from Asia, where the non-official app stores are very, very popular. About 99.5% of the malware that we see of this type comes from a non-official app store. So a simple rule to put in place if you're an enterprise and you're in a position to control that: do not allow downloads from non-official app stores. You just don't know what you're getting. And about 50% of the malware, the financial model is SMS fraud, forcing your phone to make SMS calls to a number that the attacker controls so that they can earn a few cents every time. Because the apps are really custom web browsers, we still have to deal with web-based attacks that we would have dealt with in a browser. This is that screenshot is from, I did a blog about a year ago where we found the ESPN application had a cross-site scripting vulnerability in it. And you wouldn't think cross-site scripting, that's a web app vulnerability. Yeah, but these are just windows to web app content. So even though these are client-side applications, they can suffer from web-based vulnerabilities. Poorly coded apps is a huge problem. I'll pick on the ESPN app again because I publicly blogged about it. You can see here, I'm creating an account, and in the red text there, my password, my username and password are sent purely in clear text. Now, everywhere else it was encrypted, but at that one moment when you created it, they hadn't done a proper audit, they didn't realize that it was being passed in clear text. And of course, that only has to happen once. I mean, they did respond and they fixed it very quickly. We've analyzed a lot of iOS apps. This is a shocking statistic to me that just under 10% of the apps that we've studied they pass your password insecurely, either purely in clear text like this, or very weak encoding, like a base 64 encoding. And the app stores are not filtering this out. This was trivially easy to find. We set up a proxy, we passed the traffic through, we saw it. Apple and Google will focus on malicious apps, but they're not doing a good job looking for simple privacy violations like this. More concerning, when we see a problem like this, it's typically in all the apps, because of course the developers copy their code. So here's an example of a developer. We saw that developer passing a password in clear text. When we see that, we say, hey, what else is this developer built? Almost all the time, that same vulnerability just repeats itself over and over and over again. Adware is a big problem in Google Play. We studied the top 300 applications in all categories. It was a total of 1,800 applications approximately. 22% of the applications in the Google Play Store, these are the most popular applications, flagged as adware on at least some AV vendors. Now, it's a gray area. One man's adware is another man's legitimate advertising, right? But there's a conflict of interest there for Google in that they want to attract developers, so they want to, if I create a free app, I gotta make money somehow. And a lot of these ads are very, very aggressive in their nature. Things like air push are somewhat controversial. They will be gathering information about the end user, sharing that with advertising. And so a lot of the AV companies are flagging this as adware. And unfortunately, in the end, it's the end user that pays the price. They download an official app, their AV flags it as adware. They're in a tough position of having to make that decision. Permissions are also very, very aggressive. So we've studied just over 20,000 apps. We've done static analysis on apps in the Google Play Store. And this is what I mean when I talk about privacy. Nearly 60% of apps grab your device ID, so that's a unique identifier of your device, and they share that with third parties. They share that with advertisers. And the idea is that the advertiser can then track your behavior. They don't know it's you, they just know it's your device, but they can start to build a profile on you so that you have 10 applications that all use the same advertiser's SDK. They can start to give you crafted ads. Some people don't care. They say, that's great, I get a more appropriate ad. They say, hey, I did not give my permission for ads to be, for the advertiser to track me, and yet virtually all applications are doing this. And the App Store gatekeepers are quite happy to allow that. Beyond that, 37% have the ability to initiate a phone call. 10% have access to your contacts, and a lesser amount have the ability to read or send SMS messages on your behalf. And unfortunately, human behavior, that app gets installed, it lists all these things that the app needs to have access to. How many people actually read that? No, we just say go for it, right? So we have no idea what it does. Very, very aggressive in terms of permissions. If you're interested in knowing what an application does, this is a free tool that we posted on the web. All you have to do is you can go there, point your phone to it. It's just called Zap. Just go to zap.zscaler.com. You point your phone, use the application, then it'll just let you know what that application is doing, if it's leaking passwords, anything of that nature. You can also search if you just want to see historical results. So, what do we do about this problem? Well, the typical network architecture today, Very focused on appliances, MPLS backhaul from all the remote offices to a single location, then one or a few points of egress out to the internet so that we can inspect that traffic. Unfortunately, mobile blows us out of the water because now I've got people working all over the place. They bypass that architecture. So we need to look for solutions that can be inspecting that traffic regardless of where my end user is or what device they're on. So let me just leave you with this thought to put it in perspective. Consider 3 users in your organization, and I suspect all organizations have these people. You have that user that is in the office working at a desk all day. You have another user, let's say he's a salesperson, he takes his laptop, he's on the road, he's working from a coffee shop. And then you have a third user who's a true road warrior. Maybe your CEO is out on business, and he's on a laptop or a tablet, he's on a smartphone or a tablet working from the airport, 3G network. Do you have the same level of security for those 3 users? At this stage, I almost universally find that enterprises have to answer that no, they have very different levels of control. That user that's in the office, he's sitting behind all kinds of hardware. He's sitting behind intrusion detection systems, firewalls, IDS, IPS, all this kind of stuff. So he's quite well protected. That individual on his laptop, well, he's probably not seeing any of that hardware, but he has host-based solutions, things like antivirus, maybe HIPS on the device. But that user that's on the tablet smartphone, especially in the iOS world where nothing can run in the background, he's really completely blind. And in both of the situations where the user is outside of the organization, we're not getting visibility. We're not seeing the traffic. There's no logging. That's not making it into our SIM. So, when you leave today, think of the users in your organization. What devices do they use? What locations are they in? And do those users have equivalent levels of security? And I think you'll see if that's not the case, we have weak links in our security chain. And we need to find solutions that can level the playing field and make sure that people are protected regardless of device or location. If you want any more information, our research team is at ThreatLabZ site. My Twitter handle is there. I certainly would look forward to hearing from you. Thank you for your time.